Hello friends, welcome back to my YouTube channel. In this video, let us learn another important numerical problem from projectile motion. This question is more or less similar to question number 6, but we have to use a little bit different idea in this question. The question is as follows. A body is dropped from the top of a tower 58.8 meter high, and just at that moment another body is projected vertically upwards along the same line but from the foot of the tower with a velocity just sufficient to carry it to a 78.4 meter. When and where will the two bodies meet? This question is a little bit different because in this question the body which is projected from the bottom is just sufficient to carry it to the distance 78.4 meter. It means from this information we need to find the velocity of projection from the point C. According to this question, the height of this tower is 58.8. One body is dropped from the point A and another body is projected from the point C, and let they meet with each other at the point B. Here at the point B, according to this question, we need to find where, means what is the distance from A or distance from C they meet, and when means after how much second or how many times or how much it takes time to meet to each other if they are thrown in the same line from top and bottom of the building or tower. Now let us see the solution. Let at a distance x from the top of the tower both body meets each other. It means from A to B distance is x. From B to C distance will be automatically 58.8 minus x. So let us consider the first case. When the body is dropped, the body which is dropped from the point A, our usual formula is s is equal to ut plus half at square, and in this case the s distance travel will be x because distance travel is AB, which is x, and initial velocity is 0 because it is just dropped, so its initial velocity is 0, and then acceleration will be acceleration due to gravity, that is A will be g, so x will be half gt square. That is our equation 1. This is same like is our problem number 6. Now let us see second part. For the body which is thrown up, it means the body which is thrown from the point C, the distance travel is 58.8 minus x because distance travel from A is already x, so distance travel from C will be 58.8 minus x. Now the velocity that is sufficient to carry the distance, the body which is projected from C has the velocity which can carry this object to a distance 78.4 meter. It means after traveling distance 78.4 meter the body stops. When we throw a body from ground, it travels to a distance 78.4 and it stops. So our formula v square is equal to u square plus 2as. Our v will be 0 and we need to find the initial velocity u. We are throwing body from ground, so acceleration will be minus g and s will be 78.4. By solving this we get our u. U is initial velocity of projection. After getting initial velocity of projection, we use the same logic that we use in problem number 6, that is s is equal to ut plus half at square. S will be, for the body which is thrown up, distance travel will be 58.8 minus x, and initial velocity of projection is 39.54 into t is as it is, which we need to find this t which is unknown, and a will be minus gt square. And if we see our equation 1, then we have written x is equal to half gt square. So we can replace this half gt square from equation 1. We can replace half gt square to x. So here x will be here and x will cancel with each other, and we get our t will be 1.5 second. After 1.5 second, both the body from A and C arrives to the point B. Now using that t is equal to 1.5 second in equation 1, we get the distance of AB. Using or substituting t is equal to 1.5 second in equation 1, we get x is equal to 11.25, that is 11.25 meter from the top, or 58.5, this is 58.5, 58.8 minus x, that is 47.775 meter from the bottom. So our answer is this distance from top or this distance from bottom, and time is 1.5 second. After that time they meet with each other. Thank you very much. Happy Vijayadashami. See you in another video.